Radioactive elements emit particles and/or energy from the nuclei. These nuclear particles or energy have different effects on the nuclei of these elements. This radioactive decay process can be represented by nuclear equations which show the identity of the reactants, products, and radiation. Regents Reference Table O gives the name, notation, and symbol of the common types of radiation. Going down the chart in order, we have alpha particle, beta particle, gamma radiation, neutron, proton, and positron. As shown in the notation column, the mass number is in the upper left-hand corner of the symbol, and the atomic number or charge is the number at the lower left-hand side of the symbol. When radiation collides with a material, it can knock an electron off an atom in a material and form an ion. Such an event can alter chemical bonds, which can greatly magnify chemical and biological damage. Penetration power is the ability to pass through matter. The heavy, highly charged alpha particles are stopped by a piece of paper. The lighter, less highly charged beta particles penetrate paper, but is stopped by 0.5 centimeter sheet of metal. Because gamma has no charge or mass, they are the most penetrating, but can be stopped by several centimeters of lead. An alpha particle is a particle made up of 2 protons and 2 neutrons. Since this configuration is similar to that of a helium nucleus, it's often referred to as the helium nucleus. In terms of atomic proportions, alpha particles are considered very massive with a mass of 4 atomic mass units. Furthermore, they are also positively charged due to the 2 protons in the nucleus. This can easily wreak havoc to most tissues because of its high ionization ability. Alpha particles cannot travel across large distances and are easily stopped by paper or human skin. However, again, because of their large size, alpha particles can be very dangerous whenever ingested or inhaled. Beta particles are high-energy electrons that are emitted from an unstable nucleus. You may be wondering how an electron got into the nucleus of an atom. In fact, electrons do not exist by themselves within the nucleus. However, they are emitted when a neutron splits into a proton and an electron. Beta particles are 1,836 the size of a proton, so they have a relative mass of 0 atomic mass units and a charge of -1. Beta particles travel around the speed of light with a penetration power of about 100 times greater than that of an alpha particle. The gamma rays are high-energy electromagnetic waves similar to X-rays. Gamma rays are produced when particles undergo transitions in nuclear energy levels. They are the most penetrating and have the lowest ionization power. Although gamma rays may cause atoms to emit other particles which can cause ionization. Gamma rays are emitted alongside alpha particles and beta particles. The positron is the antiparticle of an electron. It has the same properties of an electron, with the exception of electric charge. The electron has a negative charge, while a positron has a positive charge. A positron is emitted from the nucleus when a proton is converted to a neutron. Positrons have an atomic mass or mass of 0 atomic mass units, a relative charge of +1, and they have medium or moderate ionization ability and penetration power. The following video demonstrates the effect of a powerful magnetic field on different types of radiation emitted by the radioactive matter.
The British scientist Ernest Rutherford was one of the first to show that radioactivity could consist of 3 distinct types of radiation. The 3 types differ in their response to an electric field. A source of radioactivity is passed through a hole to form a beam. The beam is directed at a fluorescent screen, which is illuminated when it is struck. In the absence of an electric field, all the radioactivity beam strikes the target at a single point. When an electric field is applied, the initial beam is separated into 3 components. One of these is deflected upward by the electric field, indicating that it is negatively charged. These radioactive emissions are called beta rays. A part of the beam is deflected downward, indicating that these particles are positively charged. These radioactive emissions are called alpha rays. Notice that the alpha particles are deflected less than the beta particles by the same electric field. This occurs because the alpha particles are more massive, but the amount of deflection is also determined by the relative energies of the different types of radiation. The portion of the original beam that is undeflected is due to radiation that is not charged. These emissions are referred to as gamma rays. Other experiments showed later that the beta rays are actually high-speed electrons. The alpha particles proved to be helium nuclei. The gamma rays are high-energy photons, analogous to X-rays.